Good morning students, welcome back to the English channel. Students, today we'll learn Maths number system for grade 9, the first chapter. So before starting the exercise, let's understand the concept of number system. Children, number system means it expresses the numbers. A system that expresses numbers. So this system we have to know the classification of numbers. So what are the types of numbers? There are mainly two types of numbers, imaginary numbers and real numbers. But nowadays we are not considering imaginary numbers, so we will focus on these real numbers. So real numbers can be classified again to irrational numbers and rational numbers, fractional numbers, integers, negative numbers, zero, positive numbers, whole numbers, natural numbers, even numbers, odd numbers, prime numbers, composite numbers. So children, if I'll give you this classification, you will not understand. I will give in detail all the types of numbers. So children, first let's understand the key points of this number system. See, this is the number line. In this line, you can get to see in the right side that is 1, 2, 3, 4, 5, etc. So all these counting numbers are called the natural numbers and that is represented by n. Again, if you will add 0 to it, then it will become the whole numbers and it can be represented by w. Again, if you will go back less than 0, then it will be -3, -4, -2, -1 up to from the infinity to 0, 1, 2, 3 again up to the positive infinity, it will be integers. That means till now whatever we are seeing in the number line, this -5, -4 up to 0 and then 1, 2, 3 up to infinity, all are called the integers. That is represented by z or I. Then again, these integers can be divided into rational and irrational numbers. So rational numbers, this is the main topic of our number system in this class. So rational number means, see children, ratio, which can be represented in the form of a ratio. That is called a rational number or in the form of a fraction like p by q, numerator and denominator, where p and q are integers. That means it can be minus negative integers or 0 or positive integers, but q should not be 0. Why children? Because if the denominator will become 0, suppose I'll write 5. 5 is a rational number because it can be written as 5 by 1. But if I'll write 5 by 0, then the answer will be 0, isn't it? But can we find out 0 multiplied by dash equal to 5? No. So it is not considered, q should not be 0. The denominator should not be 0. Next, the decimal expansion is terminating. If the rational number, the decimal expansion, when you will expand it into decimal form, that is suppose I'll take 2 by 5. Then see 2 is less than 5, so we have to take a point. Now after decimal, we'll put 4 and it comes 0.4. That is, it is terminating, it ended here. But if the decimal expansion is non-terminating and recurring or repeating, then what will happen? That is also called a rational number. That means if it is not terminating, that the decimal expansion either finishes after a particular set of digits or a particular set of digits keeps repeating itself for infinitive terms or infinite terms, then suppose I'll write 1 by 4. That is, you will find the decimal number 0.25. That means it ended here, that is terminating. But if I'll take 1 by 7, then you go on expanding it. 7, put the decimal, 7 ones are 7, again you got 30, 7 fours are 28, you got 2, 20, so 7 twos are 14. Like this you got 0.142857. Again the same will repeat, 142857. Again the same 142857. That means it is not terminating, it will not end, but it recurs, it repeats itself. So that is called a rational number. Next is irrational number. Irrational numbers is the exact opposite of rational numbers. That means which cannot be represented in the form of p by q or in the form of a fraction, in the form of a ratio. Okay, that is called irrational number. That means its decimal expansion is non-terminating and also non-recurring. For example, root 2, root 3, or 0 point, the answer will come like if you'll go on dividing the number, you will get 0.10, 100, 100, 1 4 zeros. So it will go on repeating, and also it will not repeat the same numbers. Okay, so those are called the irrational numbers. Now, all rational and irrational numbers, collectively all these are called the real numbers. Again, these real numbers can be divided into the prime number, even number, odd number, or composite numbers. Then natural numbers can be prime numbers. Prime number means a natural number that does not have any factor other than 1 and itself are called the prime numbers, like 2, 3, 5, 7, 11. Children, here look, 2 is a prime number. Okay, 2 is the only even number which is a prime number. 1 is neither prime nor composite number. Then composite numbers means divisible numbers. That is a number that has factors as 1 and itself and is named as a composite number, like 4, 6, 8, 9. These can have more than one factors. That is called the composite numbers. Now next is even numbers. Even numbers means which is divided by 2, which can be divisible by 2, which when divided by 2 gives remainder 0. Okay, it is denoted by E, where E equal to minus infinitive, minus 6, minus 4, minus 2, 0, 2, 4, 6 up to infinitive, which can be divided by, which can be divisible by 2. Okay, now odd numbers means the exact opposite, the number which when divided by 2 do not give remainder 0 are called the odd numbers. Like it is denoted by O, where O equal to odd number, that is minus 5, minus 3, minus 1, 1, 3, 5 up to infinitive, which cannot be divided by 2. Okay, which is not divisible by 2 is called the odd number. Now let's again see the types of numbers. Look at this picture, you can see the classification. See, real numbers includes both rational and irrational. Rational means all the integers and all the numbers that can be represented by P by Q or ratio form. Integers again can be negative or positive or 0. Okay, so those are integers. Then integers can be all the natural numbers and the whole numbers. That means it includes both 0 to 1, 2, 3 up to the counting numbers. Again, natural numbers can be prime numbers like 2, 5, 7, etc. Composite numbers 4, 6, 15, 16, etc. Even numbers which are divisible by 2 like 2, 4, etc. And odd numbers which cannot be divided by 2 like 1, 3, 5, 7, etc. Still there are co-prime and other numbers that we don't need to discuss here. So this is the fundamental of the number system. See, look at this picture. Real numbers includes both the rational and irrational. That means it includes both the natural numbers 1, 2, 3, whole numbers 0, 1, 2, 3, etc. integers, negative numbers, and the rational, that is minus 1 by 2 or decimal fractions or all the ratio forms numbers, and irrational numbers, that is root 2, root 3, pi, etc. which cannot be represented in the form of P by Q or in the form of ratio. So this is the concept of number system. Now let's start the exercise. So we can add 2 more points here. Like to find out rational numbers, we can find out infinite rational numbers between any two rational numbers. And there is a unique real number corresponding to every point on the number line. That means in a number line, we can get correspond to each real number. There is a unique point on the number line. That means we can get root 2, root 3, root 5. We can show all this in the number line. And next is rationalization. Rationalization of a denominator means to change the irrational denominator to rational form. We can rationalize the denominator of suppose 1 by root a plus b. Then we can multiply this by the conjugate of root a plus b. That is where a and b are the integers. We can just multiply it with the conjugate, that is root a minus b by root a minus b to rationalize the denominator or rationalize the irrational number. We'll learn all this in this exercise. So let's start the exercise. Question number 1, exercise 1.1. Is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q is not equal to 0? So children, as you know, whichever number can be expressed in the form of p by q or in the form of ratio is called rational number. So 0 can be written as 0 by any non-zero integer. So 0 by 1 or 0 by minus 2, 0 by minus 6, minus 7, whatever if you divide it by any non-zero integer, then it can become a rational number. So this statement is true. Done. Now question number 2. Find 6 rational numbers between 3 and 4. See children, we know we can find out infinite number of rational numbers between any two numbers. But the easiest way is just the question, look at the question, is asking for 6 rational numbers. So you can multiply this number with the next number. That means whatever number is asking to find out, that is 6, so that we can multiply with the 7. That means any number greater than 6. So the easiest way is we get 3 multiplied by both numerator and denominator, we have to multiply 7 by 7. So we got 21 by 7. Similarly 4 also multiply with 7 by 7, we got 28 by 7. So all these numbers in between 21 by 7 and 28 by 7, all these numbers are rational numbers like 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7. All these numbers are rational numbers. So this is the easiest way, isn't it? Now question number 3. Look at this question children. This is also exactly the same question. Find 5 rational numbers between 3 by 5 and 4 by 5. What I said, whatever the question would be asking, it is asking for 5 rational numbers. So we just have to multiply with the next number, that is 6. Okay, both with the numerator and denominator. Because if you write numerator 6 by 6 and denominator, then it will get 1. 6 by 6 is equal to 1. So we can multiply 3 by 5 into 6 by 6. So we got 18 by 30. And 4 by 5 also will multiply with the same number. So we got 4 into 6, 24 divided by 30. 5 into 6, 30. So the rational numbers between 3 by 5 and 4 by 5 are between, we got 18 by 30 and 24 by 30. All these numbers in between like 19 by 30, 20 by 30, 21 by 30 up to 24 by 30. All these are rational numbers. So we got all these 5 rational numbers. See children, in this way I have made another video for this. You must have seen that. So that is the easiest way to find the rational numbers. Now let's come to the question number 4. State whether the following statements are true or false. Give reasons for your answers. Every natural number is a whole number. So children, is it true or not? Yes, it is true. It's true because all the natural numbers, that is counting numbers, are a collection of whole numbers. Okay, so it is true. The collection of whole numbers contains all the natural numbers including 0. Okay, so this is true. Second, every integer is a whole number. Is it? No, it is false because integers can be negative or positive, but whole number contains from 0 to 1 to all the counting numbers. From 0 to, remember the number line, from 0 and more than 0 numbers comes under whole numbers. So it is, integer is not a whole number. Third question, every rational number is a whole number. No, this is also false. Why children? Because rational numbers may be fractional, but whole number should be a positive number, isn't it? So for example, 1 by 2, 1 by 5, this rational number, but it is not a whole number. Done. Let's do the exercise 1.2. Okay, what is the first question? Yes, state whether the following statements are true or false. Justify your answers. See children, again true and false. Every irrational number is a real number. Yes, it is true because real number contains both rational and irrational numbers. Second question, every point on the number line is of the form root m, where m is a natural number. Is it true? No children, it is false because negative numbers cannot be expressed in the form of a square root. We cannot say the 4 root over of 4 is minus 2. isn't it? So it is wrong that we cannot express the negative numbers. Third, every real number is an irrational number. Is it true? No, children, this is also false. Why? Because real number again contains both rational and irrational numbers. So every real number cannot be only irrational number. Second question, add the square roots of a positive integer irrational. If not, give an example of the square root of a number that is a rational number. The same thing that we discussed in the first question. See children, if numbers such as if you will get a root over of 4, root over of 9, root over of 16, then what we will get? Root 4 equal to 2, root 9 equal to 3, root 16 equal to 4. And all these numbers are rational numbers because 2 can be written as 2 by 1, 3 can be written by as 3 by 1. So these can be written in the form of a ratio or P by Q. So square roots of all positive integers are not irrational. Done? It cannot be irrational. Third question. So how root 5 can be represented on a number line? See children, this is we have to draw. See children, this is root 5. So root 5 can also be written as root 2 square plus 1 square, isn't it? Because root over 4 equal to 2. So we can write as root over 2 square plus 1 square. As from the Pythagoras theorem, we know that in OB square, that means hypotenuse square, is equal to OA square plus AB square. Let's draw the number line. Take 2 units from O and represent the point as A. Okay, because first one should be 2 centimeter and AB should be 1 centimeter. At A, draw perpendicular and mark B such that AB equal to 1 unit. Now with the O as the center, you have to draw a radius of OB. Okay, that draw an arc to cut the number line so that it can cut the number line at C, or wherever it cuts, you give the name as C. Now C will be what? C will represent, yes, root 5, because root over of OA square plus AB square is equal to 5 and OB is root over 5. So you got the OC, that is root 5. Got? Done? Thanks for watching. If you have any doubt, put in the comment. I will make the videos on that same chapter. Like, share and subscribe and comment for information.